Hi, everyone. We're so glad you could join us today for Textile Printing 4.0 with Johnny Shell and Tova Williams. We're excited about this webinar and so glad you guys took the time to join us. I'm going to go ahead and turn it over to Tova, who's going to be the moderator for this session, and we look forward to your participation.
Awesome. Thank you so much, Kim. Hello again, everyone. We're super excited to have you here. Thank you so much for joining today's webinar. It's going to be an awesome one. This is going to be a preview of what's to come at our Inspired Innovations in Textile Printing Conference, which is coming up in about a couple of weeks, which is insane. This time is going by so fast. Before we begin, just a reminder that the early bird registration deadline will close this Wednesday for that conference. So Wednesday, October 22nd. If you haven't already, there's about 80 people plan to attend this webinar. So we know not all 80 of you are registered. So if you haven't already, make sure that you register. Don't wait. Visit AATCC's website to learn more and secure your spot. And again, today's webinar is going to be a preview of that conference or an appetizer for the exciting lineup of speakers and sessions we have planned for the full conference. Just a few housekeeping rules before we start. If you have a question at any point, we welcome them, but we want you to put them in the chat during Johnny's presentation. So just use the chat feature to submit your questions. We'll pause at several points throughout the webinar to address questions, and then we'll have a dedicated final Q&A at the very end. All right, so I'll take this time to introduce myself. For those of you that I've yet to meet, hello, I'm Tova Williams Cherry, and I'm an assistant professor at NC State, Go Pack. I'm in the Wilson College of Textiles, and I lead the Sustainable Dye Chemistry Lab there. As principal investigator, my work focuses on advancing eco-friendly solutions for colorants and coloration processes. So naturally, I love all things dyes and color. And I'm one of the co-chairs for the Inspired conference coming up. So I'm really excited for today's presentation. All right, so I'm thrilled to introduce today's speaker, Johnny Shell. Johnny Shell is Senior Principal Analyst for Textile Apparel and Wide Format Printing Services at Keypoint Intelligence. Johnny helps clients navigate industry challenges, innovate processes, and drive sustainable growth. He brings nearly 40 years of experience in the digital textile, apparel, decorating, and wide format printing industries. His expertise has been instrumental in helping clients enhance performance, understand market trends, and identify new opportunities in emerging applications. A thought leader, experienced printer, and strategic advisor, Johnny combines deep industry knowledge with hands-on experience to help companies stay ahead in this rapidly evolving field. If you haven't heard Johnny speak, he's amazing. You're in for a wonderful presentation. Before I hand things over to him, though, as a reminder, please continue to drop your questions in the chat. Keep yourself muted for now. We'll pause periodically to address your questions, and we'll have time at the end for more Q&A. With that being said, I'll hand things over to Johnny.
Well, thank you for such a wonderful introduction. I can tell you have great writing skills, Tova. I appreciate that. So yeah, I'm going to talk to you guys today about what's going on with AI and automation and textile printing, and really going to start the session with some industry context, just kind of step through some basic things we should understand before jumping onto the AI and automation bandwagon. Then I'm going to talk about some of the functional roles of AI in textile printing and what is currently being done in its very infancy, and then what is expected, in the years to come. We'll talk about some automation strategies across the workflow that I've seen being used, and kind of things that are evolving in that space, and then what the operational gains are of AI in smart manufacturing. And then finally, just kind of step through sort of what a roadmap of adoption it looks like for AI and automation. And then, as Tova said, we'll have a time at the end for questions as well. So appreciate where we are. We have to really understand where we've been, and I'm sure this crowd understands this quite well. But textile printing has always been driven by a balance of creativity, technology, and production economics. And for decades, analog methods really dominated textile printing. Rotary screen printing, as you know, was really the king, capable of producing millions of meters of fabric at a relatively low cost per unit. But it required significant setup times, expensive screens, and a great deal of water and chemicals. Similar, flatbed screen printing offered more flexibility, but was still slow and resource intensive, right? The digital revolution began in the late 90s and early 2000s when inkjet technology was coming into play, and some of the first textile printers started to emerge back then. If you remember those days, it was paper-backed fabric printed with just very simple water-based inks, no durability, anything like that to speak of. And we've come a long way in such a short time, over 25 years. But so suddenly then, after digital arrived, the industry could produce these smaller batches, these prototypes, highly detailed designs without engraving screens. Direct-to-garment technology emerged, and that opened up decorated apparel markets to one-offs and short-run production. And then more recently, we've seen direct-to-film that has further expanded customization capabilities. So why do we now talk about textile printing 4.0? And really, it's because of the challenges that the industry is facing today, and they're really different from those the industry faced in the early digital era. Back then, the value proposition was all about flexibility and customization, whereas today, demands are more for speed, efficiency, sustainability, and predictability. Digital printing as a standalone technology has matured, but now the conversation is about integration, intelligence, automation, linking machines, sensors, software, all these things, linking them into an intelligent ecosystem. And you'll hear that term a lot, ecosystem, and into an intelligent ecosystem that can predict, it can adapt, and it can self-correct in real time. So this is the reason why we are entering this new phase, not just digital printing, but smart, interconnected manufacturing that's being driven by AI and automation. So when we talk about textile printing 4.0, we're aligning the broader concept of industry 4.0, the ongoing transformation of traditional manufacturing into smart connected ecosystems. And in this phase of textile printing, machines no longer operate in isolation. Printers, dryers, finishers, conveyors all communicate with each other using IoT sensors that constantly capture data on everything from humidity and temperature and ink viscosity, substrate movement, the machine status, drying temperatures, all these kind of things. And AI systems interpret all that data and make real-time decisions, adjusting everything from dryer settings, recalibrating color output, or predicting when a nozzle may fail in a printhead. So automation kind of ties it all together. Robotic systems handle repetitive manual tasks like loading rolls or folding garments, while integrated workflow software is ensuring jobs move seamlessly from file preparation to final packaging. And what makes this transformation strategic is the convergence of AI and automation. AI provides the intelligence, pattern recognition, predictive control, image optimization, all those kind of things. And automation provides execution, the robots, the conveyors, the sensors, and control systems that act on AI's recommendations. So together they create a production environment that is not reactive, but predictive and adaptive. And this shift from machines that require constant operator oversight to systems that are self-managing, self-diagnosing, and in many cases self-correcting, this is really what is the defining characteristic of textile printing 4.0. So the push towards this textile printing 4.0 is not really happening in a vacuum. It's driven by very real market forces. First, labor costs are rising globally. And it's even harder to find labor, right? Skilled labor who wants to work in printing now. Even in regions traditionally known for low-cost manufacturing, the wages are climbing. I'm thinking of the middle class in China. A lot of work now is moving away from China because the labor there is more expensive than, say, places like Vietnam or Cambodia or Bangladesh, India. At the same time, those labor shortages are becoming more common, particularly, like I say, for these skilled operators. And so automation becomes an answer not only to cost, but also to availability. Second, consumer expectations have shifted dramatically, right? The fast availability of fast fashion has trained consumers to expect near instant product availability. At the same time, customization and personalization are no longer niche, they're mainstream. Whether it's a custom t-shirt, a limited run decor fabric, or a seasonal capsule collection, the demand is for rapid response and flexibility at scales. Third, sustainability pressures are intensifying each and every day. Water and chemical usage are under constant scrutiny, and energy efficiency is becoming a compliance requirement in many regions to comply with laws and regulations. So brands and regulators alike are really pushing for transparent reporting of environmental impact. And so AI and automation directly support these goals by reducing waste, minimizing rework, and optimizing energy consumption. So when you put all this together, there's these three trends: labor, customization, and sustainability. They form this perfect storm. They create the need for smarter, leaner, and more adaptive manufacturing systems. And they explain why the adoption of AI and automation is accelerating right now. So really the goal and learning objectives for this session are designed to give you folks a structured understanding of this transformation as it's happening before our very eyes. First, we'll define the functional roles of AI in textile printing. And so this means breaking down exactly what AI does, how it applies machine learning, computer vision, and predictive models to tasks like color management, detecting defects, predictive maintenance, those kind of things. Second, we'll examine automation strategies across the workflow. We'll look at how automation is applied, not just at the printing stage, but across the entire chain, from file prep, substrate handling, and even inline inspection, all the way through finishing, packaging, and even integration with ERP and MIS platforms. And then third, we'll quantify, the operational benefits. We'll look at what kind of uptime improvements folks are realizing from integrating AI and automation. We'll see some error reduction rates and energy savings are realistic when AI and automation are applied strategically. So we'll take a look at all that. And so by the end of the session, you should be able to see how these elements come together in a cohesive strategy. More importantly, though, you'll leave with a roadmap for how to think about these technologies in the context of your own businesses. I don't know if we have any textile printers and manufacturers. I'm hoping we do. But it kind of gives you a roadmap, like I said at the beginning. So let's talk about the functional roles of AI in textile printing. One of the most advanced applications of AI in textile printing is pattern recognition. So using computer vision camera systems essentially mounted on the printers themselves, AI systems can scan fabrics in real time, and they look for defects or inconsistencies and repeat patterns. Now, traditionally, an operator might only notice a repeat error after several meters of fabric had been printed, but AI intervenes instantly. So identifying the issue and correcting it before it escalates really helps save, a lot of material. So that's a good thing. And then the benefits are clear: less waste, obviously, more consistency, and higher throughput. This also frees the operator from the nearly impossible task of visually monitoring every meter of fabric. Instead, operators can trust the system to handle detecting these errors, correcting them, or raising a flag or sounding an alarm. And so then, you get a higher level of oversight by the operator instead of, down in the trenches watching every inch as it comes off the printer. Color management's a huge challenge in textile printing, and it's really just really because of the substrates. They're so variable, right? And they have different topographies and densities, and cotton and polyester and blends and specialty fabrics all absorbing differently. So add in environmental factors like humidity, and you have a constantly shifting target. And so AI can give a solution by applying real-time corrections and predictive color matching. Instead of relying solely on a static ICC profile, AI evaluates ink laydown, fabric absorption, and even drying conditions as the job is running, and can make adjustments automatically to keep the colors consistent. The benefits are fewer mismatches, obviously, reduced reprints, and greater confidence in batch-to-batch consistency. And this is particularly valuable in markets where color fidelity is critical. Certainly branded apparel or decor fabrics come to mind there, where even the smallest deviation can lead to costly rejects. Predictive maintenance is about using AI to anticipate equipment issues before they cause downtime. So onboard sensors monitor things like vibration and nozzle performance and temperature and ink viscosity. And this data feeds into predictive models that forecast when a component is likely to fail. Now, that brings to question, oh my gosh, am I going to be replacing more print heads? And I must interject here, AI works with data, and with the less data you have, then the more risk you run. So the more data you have over time, then AI learns, is adaptive learning, and over time, predicting when a component is likely to fail is going to become much more accurate. But we have to build those data sets first, and that's what takes time. So the idea is, instead of running something until it breaks or servicing equipment on a rigid schedule, predictive maintenance will then allow intervention at exactly the right moment. And so that results in reduced unplanned downtime, lower maintenance costs, and extended machine life. So this shift from reactive to predictive management is one of the most powerful ways AI delivers measurable ROI in textile printing. Defect detection, I mentioned this earlier, is another area where AI is providing a big leap in capability. High-speed cameras that are mounted on the printers themselves using computer vision software will monitor fabric in real time, identifying any flaws such as streaks or nozzle clogs or any kind of scratches, or say a piece of lint gets caught on the print head and it drags across the wet ink. Things like that can be identified soon, and the printer can be stopped and the problem resolved. But the system doesn't just spot the defects; it actually classifies them and logs the data, creating a traceable record of where and when they occurred. Going back to what I said previously, the more data we have, then the more accurate AI is going to be in identifying defects. Right now, we just don't have a data set of defects, right? Who among us has, a cabinet or a locker or what have you, a filing cabinet full of print defects just sitting there, right? We don't really do that. Well, we have to start doing that so AI can learn and become adaptive in the environment that it's being asked to work in. And identifying these issues. So, but it will log that data and again create that traceable record where it occurred, when it occurred, what machine it occurred, all those kind of things. And so that information is then used to identify recurring issues and drive continuous improvement. That's what it's all about. So if machine number 5 is constantly getting these things, well, maybe we need to look at machine number 5 and figure out if it's, time to retire it, or if, something else can be done to make it more efficient in production. And so these benefits are, certainly produce less waste, faster quality interventions, improved customer satisfaction, because defective fabric is intercepted before it ever reaches the customer. Now, AI is not limited to the production floor, although there's a lot of things going on at production floor, but it really plays a role in how products are conceived and designed. So customer personalization models use data to generate designs and predict consumer demand, or what should be trending next week based on trends of this week. And so that allows textile producers to respond to these micro trends very rapidly, reducing time to market from weeks to maybe just a couple of days. It also makes mass customization viable, meaning each customer can have a product that feels unique without disrupting the efficiency of large-scale production. So the outcome is stronger consumer engagement because they're getting customized and personalized products. Reduces the risk of overproduction, meaning we don't have to make 500,000 red dresses with pink flowers. We wait till the consumer trends tell us that's what they want, right? And it also gives us the ability to offer highly personalized experiences at scale. Now, one of the coolest things, and it's a pretty new concept. It's called a digital twin. It's essentially a virtual model of a production line or process. It allows producers to simulate jobs, test workflows, and predict outcomes before committing resources. And so by simulating runs virtually, these digital twins can reduce setup waste and accelerate problem solving. They also serve as powerful training tools, giving operators a safe environment to practice before handling live production. The benefits are better planning, obviously, fewer errors, and a more skilled workforce ready to handle real-world challenges. If you know the company Black Swan Textiles, they use production digital twins as part of their operations. Keith Hoover, you may know. I think Frank Henderson's involved as well. But they're using digital twins as a way to simulate production before they even go to production. So another company called MTEX, they did a academic industry implementation using a digital twin architecture for textile and garment manufacturing. And there, the system integrates data from legacy and modern machines and gives them the ability to predictive maintenance, right, and anomaly detection much quicker. So these digital twins are certainly something to keep your eye on for sure, because I think they're going to be more and more popular as the capabilities advance. And then what is AI without data analytics? And what this does is really converts all this massive amounts of production data into clear insights, right? This includes identifying bottlenecks, highlighting inefficiencies, recommending optimizations for ink or energy, substrate usage, all these kind of things. So dashboards are produced with the AI data analytics tools that are available. And so these dashboards give the operators and managers real-time visibility into performance metrics, which allow for faster data-driven decisions. Instead of relying on just intuition or gut feeling or retrospective reports, well, this is what happened last time. Production personnel can act immediately when issues arise. The benefits are, again, improved efficiency, optimized resource consumption, and a stronger foundation for continuous improvement. So when we put all these applications together, pattern recognition, predictive maintenance, detecting defects, personalization models, digital twins, and data analytics, the combined effect is really transformative. We see measurable improvements in uptime because machines anticipate problems before they cause downtime. Energy use is reduced because processes are optimized continuously. Consistency improves because every stage of production is monitored and corrected in real time. And these benefits form really a foundation for this textile printing 4.0 and sort of demonstrate why AI is no longer optional. It's becoming essential to stay competitive. So we'll pause here. Tova, I don't know if we've gotten any questions so far, but we'll pause for a moment, see if anything came in.
Let's see. I'm gonna wait for them to come in. So just a reminder, you can put your questions in the chat. While we're waiting for questions in the chat, I do have a question. I wonder if it's the right time to ask it. So no problem if you want to wait to ask this. I have another question potentially to ask. So you definitely have started talking about how AI is transforming textile printing, the various ways, which were really helpful to see those concrete examples. Um, like I said, if it's more appropriate to ask this later, please do answer later. 5.0. So we're talking about 4.0. What would you say maybe based on the examples you've seen you might see in 5.0 or the examples that you gave,
Yeah.
something that might look like a little bit different for 5.0?
Yeah,
That makes
well,
sense.
I think, 5.0, we're going to be much closer to lights out manufacturing. Robotics are going to be a lot better. Now, I'm not saying, 5.0 is going to happen next year, but we're working toward that now, where it's complete lights out manufacturing. Robots are doing the majority of the work, and really, human labor is more for maintenance and repair, um, materials, restocking materials, those kind of activities. But um, that's kind of how I see 5.0 taking shape, with everything from auto registration, printhead alignment, predictive maintenance is going to get better, remote diagnostics and digital twins is going to get much better. The workflow will be optimized, certainly, in a much better way. We'll see more software intelligence away from the printer. So um, sensing demand and production planning, um, sustainability accounts, right? Accounting for sustainability, because we have all these standards and certifications that have to be met, and all that has to have documentation. So right now, that's still a pretty labor intensive process, but I see that becoming much more automated as AI gets more and more involved at the software level, where it can pull all this data that all these certifications require and format it into essentially a finished report that can simply be handed or sent, by email over to the certifying body itself. So,
Okay, awesome. Thank you. We have a couple of questions in the chat. I'll ask them and then we'll proceed with the
okay.
rest of the webinar after you answer them. So from Carrie, as AI applications are developing, are vendors looking to enable system upgrades to manage capital expenditure challenges?
Well, that's a great question. And I can
Mhm.
tell you that I'm seeing more and more machines come to market now that are upgradable in the field, meaning, um, the printer can have up to 4 print heads. The standard model you buy is 2 heads. So you buy the standard model, and then, uh, as your profits grow because of that new printer, then later on you can upgrade to more heads, and it's not a situation where you've got to buy a new printer. So all that's kind of coming to light now. But yeah, over the last year or so, I've seen several field upgradable devices coming to market. So that's only going to get more and more prominent, I think, in the industry as people, try to grow their businesses and can't afford a huge capital investment right out of the gate, these field upgradable devices are a way to get their foot in the door and upgrade as their business grows.
Awesome. And I think that addresses one of the other questions, at least partially. And if I say your name incorrectly, I apologize. I believe Canty, your question that Johnny just answered, at least partially. We'll ask one more and then we'll move on for the sake of time. And if you didn't get your question answered right now, there'll be other opportunities. So from Beth, how can digital twinning help a pattern designer when making custom textile merchandise like scarves and t-shirts?
Well, the digital twin doesn't really help with pattern designing. The digital twin just merely allows you to simulate production and see if any issues arise. Again, AI works a lot on data. So let's say I've got this very stretchy fabric. I can run a digital twin of printing that fabric and see how much skew and things like that are going to come into play in production. Do I need to make any adjustments with print speed so that I reduce the amount of skew? Things like that are really what the digital twins are more for.
Okay, we look forward to the rest of the webinar. Again, we'll have another period for Q&A soon.
Okay. All right. So we'll move now into automation strategies across the workflow. And so just talk about some ways folks are doing automation. So we'll start with robotics. And, in textile printing, robotics are are increasingly used more and more for tasks like loading and unloading fabric rolls, aligning substrates, transferring materials between stages of production. That's where a lot of robotics is taking place. It's not so much in print production as much as it is just moving materials from one stage to the next. But the benefits are kind of threefold, really. First, automation reduces the amount of manual labor required, obviously. So that certainly lowers costs and mitigates labor shortages. Robotic handling ensures consistency. So substrates are loaded precisely every time within, 1.5 millimeters or so. I mean, it's very precise. So that minimizes errors that can lead to waste. And then third, worker safety improves, right? Because repetitive heavy lifting and awkward manual handling are removed from the operator's responsibility. It's now part of the robot's job to do all that. And so safety of workers is improved. So robotics don't replace the operator, they free the operator to focus on higher value tasks such as quality oversight, troubleshooting, workflow optimization, those kind of things. But you can see the photo here of this robotic arm kind of picking this fabric up and moving it around and putting it back down. We're still in the very early stages of robotics. And I've got a few other slides here in a minute that I'll have some different photos of. But robotics are coming. It's just textiles, as you know, it's a very flexible and fluid fabric. So it's not like moving a piece of foam board, right? Where you can just pick it up and everything moves together. That's one of the biggest challenges in robotic sewing right now is just the fabric itself and how to keep it straight and not wrinkled and all those kind of things. And you've seen all the different solutions from, spraying the fabric with something that makes it rigid so the robotic sewing machine can move it around and keep it kind of in place. And not folding up on itself. We've seen a lot of automation and finishing as well. Cutting, we've had automatic cutters for almost 20 years now or more. Steaming, washing, sewing are critical to overall product quality, and automation in this stage really ensures that the gains made during printing are carried through to the finished product, right? So automated cutting systems, for instance, will adjust blade angles or laser intensity based on fabric thickness and elasticity or fabric composition. And then AI-controlled steaming and drying systems adapt automatically to substate requirements, reducing both under and over processing, which is certainly going to save some water, maximize that whole end of things. So the benefits here are really shorter turnaround times, consistent quality across runs, and fewer errors that are being introduced late in the workflow. And then packaging, once the product is finished, let's say a t-shirt or a garment or a piece of apparel, it has to be packaged, and that's really where robotics are being used quite a bit. Folding fabrics, you can see in the top right there, that robot that's folding that t-shirt. You can see in the lower photograph there on the right where it's moving the folded garment to a collection bin for sorting. So and this is where automation really delivers efficiency. Robots can, like I say, fold the textile. They can put them in a bag, apply labels, and that's all valuable in the e-commerce world, right? Where order volumes can spike dramatically and speed is critical. So all this robotic stuff is being used quite extensively in a lot of e-commerce places I've been, that it's just a constant flow of orders, and each one has to be efficiently produced. Otherwise, it creates bottlenecks. So, but automated packaging reduces manual labor, obviously, accelerates the fulfillment process, and then ensures that consistent presentation. By minimizing manual labor, it also reduces errors and mislabeling, things like that, incorrect folding, all these kind of things. Robots don't get tired. They don't need time off. They don't take vacation. They do break, so you gotta have some backup in place, or ways to fix them when they do break. But they're pretty consistent once they're running. IoT sensors. So environmental conditions like temperature and humidity have a direct impact on textile printing, as you know. And so IoT sensors on board the printers and other hardware in the workflow give consistent flow of data on all these variables: ink viscosity, dryer conditions, humidity, machine status. And so all that data, like I said, is fed into an AI-driven system that can make real-time adjustments. For example, automatically adjusting dryer temperature when humidity increases, or modifying ink flow when viscosity changes. So the benefits are, again, reduced waste, consistent print quality, and fewer production errors tied to environmental fluctuations. And that's what the whole goal of these IoT sensors is about. So essentially, they make the printing environment just more predictable, which in turn makes the output more reliable. And then integrated MIS and ERP. So AI can certainly help in this, right? It's a connected ecosystem, and you can't just stop at printing. It goes well outside of the printing circle. So one critical part of smart manufacturing is the integration of management information systems, MIS, and enterprise resource planning, ERP, with the production workflows. So when these are all connected directly to the production environment, to the machines themselves, every print job automatically updates on costs, material usage, inventory levels in real time. And so managers through dashboards can gain complete visibility of everything that's going on regarding production performance, order status, delays, all these kind of things. And so instead of all that being manually collected in the past, AI is now allowing all these systems to talk to each other and give production managers and production personnel the visibility to see inside their production floor. And again, the benefits are pretty clear here. Fewer administrative errors from handwriting things, or losing forms, something fell in the trash, more accurate cost tracking, really enterprise-wide consistency that extends from the office to the production floor. And so now let's look at cloud workflow platforms. And cloud workflow is becoming more and more popular. Everything's stored in the cloud. They really centralize job scheduling and provide real-time monitoring of production equipment across multiple sites. So let's say I've got a factory in Vietnam, I've got one in Honduras, and I've got one in Los Angeles, right? If everything's on the cloud, then I can see job scheduling and real-time monitoring of everything across all these different sites whenever I choose, right? And so with this cloud-based oversight, we can view equipment status, job progress, quality metrics, really from anywhere. I could be sitting on the beach down in Mexico with an umbrella drink, and I can check on my printers, right? And what this does is just kind of standardizes across global operations. That's really what it's about. So a job produced in one location matches near perfectly with one produced somewhere else, right? And that the benefit there is scalability, transparency, and the ability to manage complex multi-site operations more efficiently. So that kind of any questions on automation strategies?
All right, so if you can put your questions in the chat again, that would be great. So it looks like we got a question from Carrie. She said, development of cloud workflow platforms is exciting. However, it seems like most of these solutions are focused on garment or product printing as opposed to fabric links. So maybe it's a comment. Would you echo that, or hopefully I'm not?
Yeah, I mean, I think that's true to some extent for sure. Printing's the easy part, I think, right? And so yeah, to have it's an uphill climb to get all the different fabric inventories and colors and patterns and all that stuff, first of all, into the cloud, and then being able to monitor it, across multiple sites on a global scale. So, but yeah, certainly printing is one of the easier parts of cloud, right, for color consistency and things like that. But you're right, Carrie, it does get a little more involved when you're talking about the fabric itself. That's another webinar.
Got it. I think for now, we'll just take this one question since I don't see others in the chat, and then we can revisit questions again later. Thank you, Johnny.
Okay, sure. All right, so let's move into some operational gains of smart manufacturing. Got some data here that I can share with you. One of the most important metrics really to evaluate in smart manufacturing is uptime. And that's just the percentage of time your equipment is actually producing sellable output. And many traditional environments, downtime, whether it was planned or unplanned, usually eroded productivity far more than managers realize. So with AI and automation, though, uptime gains of anywhere from 15 to 30% are typical. I've been in many places where AI gains from everything I've talked about here. 30 was the low, and I haven't seen anybody 100% plus, right? Nobody's there yet, but certainly measurable gains that are worth noting, right? And they usually come from three areas, right? First, reduction of idle time through automation of job changeovers. That's first. Second, the ability of predictive maintenance to anticipate failures and prevent unplanned stoppages. And then third, the speed of recovery when interruptions do occur, because systems can recalibrate themselves automatically. It doesn't take a color technician to come in, print an ICC profile, scan it, go into the software, read it. Okay, let's do this. Let's change this. Let's pull back the ink limits, what have you. Do it again, right? AI can do all that on the fly. And so what all this means really is more capacity without adding new machines. If you can lift uptime by even 15%, you've effectively expanded your production capability without a single new piece of hardware. So that's one of the clearest demonstrations of ROI in this new phase of digital textile printing that AI can deliver. Error reduction is another major drain on efficiency. So every misprint means wasted fabric, wasted ink, wasted time, wasted energy. And rework not only costs money, but also disrupts production schedules and delays delivery to the customer. So AI-powered quality control changes that dynamic. And inline inspection, as I mentioned, with advanced vision technology, are capable of detecting defects above 90%, right? So that's pretty good. That means the vast majority of errors are caught in real time, as opposed to after several meters or rolls of fabric are printed. So it's detected before these errors accumulate into a lot of waste. So, and because they're detected and corrected immediately, so rework declines. So that means more time added to production capacity instead of, we never have time to do it right, but we always got a time to do it over, right? Scrap rates fall. Operator interventions shift from firefighting to prevention. So the benefit here is really twofold, I guess: lower material costs and improved reliability of on-time delivery. And both those are directly attributed to stronger customer satisfaction, higher profitability, all because of AI's involvement in error reduction. And then finally, energy efficiency gains. Energy is a significant cost center in textile printing and textile manufacturing, to be brutally honest, especially when we factor in the dryers and the curing systems, the steaming, the washing, climate control. And so these traditional systems consume energy at a constant rate, regardless of load or environmental conditions, right? Smart manufacturing introduces dynamic energy optimization. So dryers automatically adjust temperature profiles to match the specific fabric being processed. AI models can predict idle periods and put machines into low power states without operator intervention. Environmental sensors can fine-tune conditions to avoid overuse of heat, fans, chillers. And so the result is a reduction in certainly electricity usage, lower operating costs, obviously, but almost as important, or equally as important, if you will, energy efficiency has become a sustainable metric. So brands and regulators expect textile producers to reduce their carbon footprint and report those improvements transparently. So by linking energy efficiency to both compliance and cost savings, AI and automation provide a dual advantage. And like I said, it's and meeting the requirements of these standards like GOTS or Ecotex or what have you. AI can literally generate a environmental report that says, here was our footprint over the last 30 days. Here's the water usage, energy usage, what have you. And that transparency, but also the time and effort saved and tracking all that data and someone having to manually fill out all that stuff is a definite advantage. So questions on any kind of operational gains, smart manufacturing? We got about 10 minutes left, so we're doing good on time.
Yes. So I'll see if anyone has any questions in the chat. Give it a couple of seconds. Sometimes they come in a little
No worries.
delayed. Now, I do have a question that isn't necessarily related to this section, but just in general, um, that I guess we can get answered now.
Sure.
So something that's been on my mind is, this fear of AI and it taking over jobs, right? And maybe it's a US thing, I don't know. But my question is, do you see that as it relates to this technology? And if so, is it more so in areas where there's not as strong of a need? And by areas, I mean regions, so like countries. Um, I'm just wondering if there's a correlation between like if there's a really great need for AI because maybe there's not enough workforce there.
Right.
Um, do you see less fear of AI to be incorporated into work systems?
Yeah. Well, I mean, I think we're all afraid of AI because we don't understand it and what it's capable of doing.
Mhm.
But in terms of, how the human role may change, I see that really, it's going to require a different skill set. It's not going to replace operators. We're going to move really from operators to technologists, right? So you're going to have folks that are monitoring dashboards for exceptions, validating AI recommendations, managing recipe libraries for a given fabric, let's say, right? Color and material specialists that less time on manually calibrating and profiling a printer, more time on defining acceptable um, prints. Remember we talked about the defects, how we just don't have that data set, right? Nobody's saved all these defective prints that we've been doing all this time. But now we have to kind of think in those terms because that's how AI is going to get better, is if we feed it more and more data, right? Um, Reliability analysts, think about that, right? Interpret health signals of the printer. Is that print head actually going to go down? And I know I said earlier that AI is going to get better and better at doing that, but we're still going to need somebody to, um, you know, is this reliable, right? And more of a captain in charge or a bus driver, I guess you'd call them, where they're in charge of, okay, yeah, it's a valid thing that AI has brought up here. We probably should go ahead and change that print head, or coordinate planned maintenance or what have you, right? So I think there's going to be cross-functional skills, right? Data, you're going to have more data literacy requirements, workflow integrations with API basic things like that, sustainability reporting where mapping jobs to reach and GOTS and all these other metrics and certifications. And so there's going to be a new training footprint. It's going to be um, different than what we have now for sure. But I don't see AI necessarily um, taking away jobs. I think the jobs are going to evolve into a different skill set.
I see. Got it. Makes sense.
Yeah.
Um, I'm gonna go back and ask a question that I think you answered in the first section, but maybe you can elaborate a little bit more. And again, if I say your name incorrectly, I'm sorry. Canty, they asked, there's no question AI is going to significantly change the printing and the entire textile industry. What do you see cost of capital investments in AI learning cost before it can be reliably functional?
I think that's going to depend on the organization, the size, the number of employees, the production capacity. All these things are going to determine your budget. And I mean, this next section I'm going to go through is on sort of the roadmap for adoption. So maybe that'll kind of let me put that on pause, and then we'll come back to it after this next section. How's that?
Yeah, sounds good.
Okay.
Thanks.
Yep. So yeah, what does the roadmap to adoption look like? I think before anybody moves forward with AI and automation, it's really critical to assess your organization's readiness. And it starts with an infrastructure audit. Are your machines connected, or are they still operating in silos? Do you have the networking capability to transmit and capture production data? Second, your workforce. We just talked about this, operators and managers in a smart manufacturing environment, they need to have new skills. Instead of a manual intervention, they must now be comfortable reading dashboards, interpreting analytics, and trusting these automated decisions that AI is going to be doing. So training and reskilling are going to be key parts of that journey. And then last thing is conduct ROI modeling. So that means, investments in AI and automation are going to come with significant upfront costs. So you need to demonstrate the business case for that. And so ROI modeling can help you do that. And it really needs to include not only efficiency and uptime gains, but also reductions in waste, labor dependency, energy uses, these kind of things. So when framed correctly, all this stuff can show that adoption is not just a cost, it really can be a profitability strategy. And it's a different way to look at it. So don't look at it just in terms of cost, because you have to really take into consideration all the gains you're going to get from AI and automation. Implementation, once you've kind of done your audit and you've said, okay, we're ready to go forward, you can't. Implementation is not an overnight transformation. You don't just flip a switch and it happens, right? The most successful strategies start with pilot projects. Identify one line, one process, or one task where AI and automation can deliver quick, visible results. Then roll it out in phases. Each phase should build on the last one, expanding from isolated use cases to integrated systems. And so that minimizes disruption while building confidence across the organization, because there are a lot of skeptics with AI. It's here to take my job. I don't like it. I'm afraid of it. All these kind of things. So you have to really engage your workforce and build their confidence across the entire organization. Make them a part of the implementation process, right? Help them understand how it's going to help them do their jobs better and more efficiently. And then finally, strong vendor partnerships, right? I can't stress that enough. The right partners provide not just the equipment, but also training, technical support, integration expertise. So implementation is not just about buying machines, it's about building a long-term capability. So strategic partnerships make that possible. And I would certainly engage with the printer hardware vendors, the RIP software vendors, ERP and MIS software vendors. All these folks need to be kind of in the same room talking to each other, and to allow the full ecosystem to be interconnected and work properly. And then every adoption journey comes with barriers, right? So the first is cost. We just talked about this. AI platforms, sensors, robotics, workflow systems, they all require a financial investment. And really, the key is to address cost concerns with a strong ROI projections that show payback over time. That's why it's so important to do those ROI models. The second barrier is legacy equipment integration, right? Not everybody's equipment is as modern as it will need to be for AI integration, right? Many factories still run older machines that were never designed for connectivity. Middleware solutions and retrofitting are often required to bring these assets into a smart ecosystem. And then third, and often the hardest barrier, is change management. We just talked about this a little bit. People are naturally resistant to change. It's here for my job. I don't like it. I don't want to work with it. They fear automation might replace their roles. And so the reality is that automation shifts human responsibility to higher value tasks. You have to really make that clear in this transformation. So clear communication, training, involvement of the staff, as I mentioned, engage them, build their confidence in this transition are all essential. And without buy-in from your workforce, even the best technology is going to struggle to deliver results. And then just in terms of outlook, this is kind of just my opinion based on just kind of what I'm seeing and where I think it's going to go. So the roadmap is we're just a mile down the road right now, and we're driving to we're driving from North Carolina, NC State, over to Los Angeles, right? And we're 1 mile down I-40 there. I see three emerging directions, right? First, generative AI for design. We haven't really talked about that, but it's getting better and better. I don't know how many of you are on some of the social media platforms where they've got AI generated videos and artwork, but it's amazing. And it makes it in no time. I mean, you want to talk about the biggest time saving is going to be in the pre-press and generative AI, right? AI algorithms can generate textile patterns automatically, responding instantly to trend data or customer input. And so that compresses the design to production cycle dramatically. I talked about digital twins. That's going to expand in scope. Instead of simulating a single machine or line, entire factories can be mirrored digitally, right? And so that's going to allow managers to simulate scheduling scenarios, energy usage, or supply chain disruptions in advance and see what countermeasures they need to prepare for in case it actually does happen. The long-term vision is really fully autonomous factories, this lights out manufacturing. And this is where orders flow in digitally, they're scheduled automatically, they're produced with minimal human intervention, and they're shipped directly to the customer. And so operators and managers are going to they're going to have to shift from controlling processes to overseeing these systems, right? And while we're not there yet, the trajectory is pretty clear. We're heading to that horizon right now. The things I've discussed today are stepping stones toward that fully autonomous future. And it's a really exciting time in textile printing. I know the industry's kind of in a lull right now, but hopefully AI will be something that will kickstart it back, because we're ready for this digital textile wave to finally break ashore. We've been waiting on it now for 10 or 15 years plus, and it just hopefully this AI and automation stuff is going to be the Kickstarter that we need to get the industry into a digital atmosphere with textile production. We can help save the planet, conserve water and energy, and all these things that digital does for us. And I'm excited to see it happen. I really am. So I want to thank you for your time today. And if there's any questions, we can spend the last remaining minutes talking about that. I see we're just over on time, but I'm happy to hang out for a few more minutes. This is my contact information. Should you have any questions once the session's over?
Awesome. Thank you so much, Johnny. I
Sure.
see a lot of people are saying thank you and whatnot in the chat.
Yeah.
Just a reminder, if you haven't already, make sure you register for Inkspired coming up November 5th through the 6th of this year at the State View Hotel in Raleigh, North Carolina. We'd love to have you. Johnny's presentation was just an appetizer for the many speakers we'll have lined up for that event. If you have other questions, please take the time to put them in the chat, or you can take this time to unmute yourself if you feel comfortable. You can also turn your video on. This part is now very informal, so whatever you're comfortable with. And thank you so much for attending. I hope you learned something new. I certainly did. And thank you so much, Johnny, as well. This was amazing.
Yeah, it was great. Thank you for having me.
Thank you both. That was a great presentation.
Yes. We got several more thank yous in the chat.
And if you think of questions after, like Johnny, he shared his contact information, so feel free to reach out to him. If you think of a question after the fact, and like Tova had indicated, we would love to see you on site at the State View November 5th and 6th. If you have any questions regarding the conference, please feel free to reach out directly to me, Kim Nicholson at AATCC. I'm all over our website, so you can find me. So I would be happy to help you get registered or answer any questions you may have. But thank you all for taking the time to join us today. And thank you, Johnny and Tova, for your time. It's been a
Thank
great
you.
session.
Thank you.
I agree.
Thank you.
Yes.
Happy to
Looking
have it.
forward to seeing everybody next month.
Yes.
Bye.
Take
Bye-bye.
care, everyone.
Bye.
Bye-bye.
Bye.